let's take a look at this. We have our diagram. Even in these examples, it's super important. If you have your digital pen, you want to pull that out because it's going to be helpful. If not, you do want to activate the little pen tool here, because remember, we want to start by marking our diagram. And if you try to do these without marking your diagram, you are much more likely to get them wrong. Marking our diagram is a key part of this process. Okay, so number one is not a congruency. It's a piece of information they gave us. And they do list that as given, so that's fine. Number two is a congruency. They tell us it's given, and we do want to mark that congruency on our diagram. So FH, this segment, is congruent to FG, this segment. So we've marked it, we've stated it, we've given a reason for it. I'm going to switch colors. We then have another congruency statement that GI right here is congruent to HI, oops, 2 marks to tell it apart from the single marks, HI right here. Why do we know that GI is congruent to HI? Looking at our problem. Tell me.
Because FI bisects GH.
Were we told bisect anywhere?
It's because of definition of midpoint.
Ah, because we were given I is the midpoint, so there is a bisection happening, but we want to connect it directly to the given. Because we were told I is the midpoint of GH, this leads, and draw that arrow, it's going to help. I is the midpoint of GH leads to GH is therefore congruent to HI. So when we choose our drop down, which of these would come from the fact that I is the midpoint of GH? Definition of midpoint. We're coming from midpoint, so our reason is definition of midpoint. All right. Then we have that FI. All right. Then we have FI is congruent to FI. This is our third set of sides, so I'm going to use 3 tick marks here. Why would FI be congruent to FI?
Because FI is FI.
Okay, what is our property that says something is congruent to itself?
It's reflective property.
Reflective property. Reflective property. Now, congruence is when we're dealing with the figures, the shapes. Equality is if we're just dealing with the measures. Okay, so we want congruence because we're dealing with the whole shape, the whole side.
Reflexive property of congruence. Knew it.
Of congruence.
Son of a.
Okay, and then because we have 1, 2, 3 pairs of sides, this would be side, side, side for the proof of our triangles. There we go.
Oh, we do have 15 minutes left. That was the 15-minute timer.
Okay, moving on to number 2.
Same answer.
All right.
Correct.
Number 2. Remember, we don't want to just jump. We want to walk our way through these proofs. Q is the midpoint of PR. That's a given. QT is congruent to PS.
Did we erase the 19 on the board?
I'll get that. Is given. Now, when it says given, it's not said given. Why is it given in this case? Because it was pre-marked for us. Yeah. In this case, it's given because it's pre-marked. QT and congruent to PS. And then QS congruent to RT, also given because it's pre-marked. And then PQ is congruent to QR. I'm going to mark that. This is my third side, so I'm using 3 tick marks. Why would PQ be congruent to QR? How would I know that, Angelina? There we go. We had our midpoint here. Q was the midpoint of PR. So this must be based on definition of midpoint. So my triangles are congruent. I know 1, 2, 3 pairs of sides. My triangles are congruent by
Definition of
keep going.
Side.
Side, because I know 3 pairs of sides. 1 pair of sides, 2 pairs of sides, 3 pairs of sides.
If you know what I mean.
Number 3.
That's enough.
All right. Number 3. W is the midpoint of SU. And I'm going to add some highlighting here. Given. W is also the midpoint of TV. Also given. SW is congruent to UW because this definition of midpoint, and TW is congruent to VW because of this definition of midpoint. Notice we're using vertical angles for our picture property, so we use our, should just be 1 angle mark, but I used 2, it's fine. 3 letter angle names because vertical angle theorem. And then this is going to ask us to type our answer. What were we asked to prove?
Triangle SVW is congruent to triangle UTW.
Okay, if that's what they asked us to prove, that is exactly the thing we need to type.
So can we just copy and paste that?
I think you can try, but I think we have to type it. Oh, nice. It does need to be that exactly, not some other rearrangement of the triangles.
Paste.
And which triangle congruence postulate proves these triangles congruent? S.
Space for
SAS. I know 2 sides and the angle included between them.
SAS.
SAS. That's it.
Sassy.
Okay, we're going to move on to the next question.
Question mark.
All right, number 4. T is the midpoint. We're going to do just 1 through 5. T is the midpoint of QS and PR. Complete the proof. All right, so we have given, we have given. We have a given because it is marked already on the diagram. PS is congruent to QR. We have QT is congruent to ST. Why?
Because God wanted it.
I do not see that as an option. All right, let's back up. We have midpoints, so let's mark the segments being midpointed. QS has T as a midpoint. PR has T as a midpoint.
P.
All right, so QT is congruent to ST because T is the midpoint of QS. T is breaking QS up into two different segments. So far we have two pieces of information.
Bless you.
What do you think we might do as a third piece of information for our triangle?
Oh.
Discuss with a partner.
You call her. It's triangle. It's triangle. Disgusting. Disgusting. Stop.
All right. Strategies, suggestions. What do you guys think? Nadine, what are you thinking? Based on what?
Well, both triangles are T-touching.
So
There would be, it's like separate triangles, so it would be PST, and then it's the T-touching to RQT.
Butterfly kiss.
okay, we have butterfly kiss, which means what? So they're touching there. What does that tell us? Corinne?
Vertical angles.
That we have vertical angles. So we can't jump straight to the triangles being congruent yet because we need 3 pairs of congruent parts, and we only have 2 pairs of congruent parts, but we could get a third pair because they're touching there, like Nadine pointed out, which would give us vertical angles. So that's one approach we could go, and I'd love to see a few people go ahead and list those vertical angles congruent and vertical angles as their reason. What's another approach we could go here? There's actually more than one way we could go. Margaret.
Find angles as congruent, like angle STP congruent to angle QTR,
Based on what?
vertical angle.
So yeah, that's one of the approaches that we could use. So that was one that we just said, STP, angle STP congruent to angle QTR, because vertical angles. But there's a completely different approach we could take. Anyone have an idea what that could be? Tommy?
What about ASI? SSA. Side angle. You mean side angle? No, side angle. Because PS is a side, and then ST is no side angle option.
So we need to find, stop jumping to the triangle. Tell me what other piece of congruent information we could find. Angelina.
Is it segment PT's congruent to TR?
We could find that segment PT is congruent to TR based on,
Definition of midpoint.
yeah, we had this other midpoint here. Oops. Erase that. And I think this is what Tommy was getting at, but when we're doing our 2-column proofs, we do have to do it more step by step rather than being able to jump around with our long ones. So we also know that PT is congruent to TR. Now, this isn't necessarily SSA because we know how many sides now? 3. So you have 2 choices. You could use vertical. Ooh, what becomes our challenge if we used vertical angle theorem?
Finding vertical angles.
Let's back it up a second. We could find our vertical angles. What happens when we mark our vertical angles?
We have to have arc marks.
So we mark our arc marks. Oops. Is this angle, side, angle, angle, side?
It's excluded. So
It's
side angle.
ooh, and can we prove triangle congruency with side, angle? Okay. So what I want us to notice here, we could even list our vertical angles congruent. There's nothing wrong with adding this because it is congruent. But we can't prove our triangles congruent with side, angle. We will have to find segment PT congruent to segment TR
Oh goodness.
because definition of midpoint which allows us to use side, side, side. So now our triangles are congruent. Can we copy paste that? Oops.
No, it doesn't let you.
Doesn't let you.
I figured it out.
Ah, okay. Triangle PST is congruent to triangle RQT because side, side, side. All right. It should, I believe, mark you correct whether you leave vertical angle theorem in there or not. Okay. It's not a problem. And that's it. So, gonna mark skip to next question. Okay, the last proof asks us to do it all ourselves. Super quick and easy. We're gonna do this real quick. Segment XY. Let's work through our givens in order. Our first one, our single mark, is XW is congruent to YZ. Remember, they do need to be capital. This is case sensitive. Capitalization matters. And then XY, our second given, segment XY is congruent to segment WZ. Also, if you know the first letter, you can hit it and it'll jump you to that in the list, which helps a lot. Given on your keyboard. All right, what third piece of information can we find?
YZ, segment YZ is congruent to segment YD.
Not YZ,
Or WY.
WY. There we go. WY is congruent to itself. WY, when something's congruent to itself, that is? No. Reflexive. Hit that R and it'll jump you in the list to reflexive property. We want of congruence, not equality. We're not dealing equalities with numbers. We want letters. That's congruence. All right, that's our three parts. Let's label the last one on our diagram. 1, 2, 3. What are we proving? Triangle. Okay, because of what? Side, side, side. So I'm going to pause right there, let you catch that up. We're just doing 1 through 5, so you can just submit this. And you know what I'll do is today, all you're going to, I'm going to pause here.